Welcome to Gamonal Tutors, where confidence breeds competence. Today we'll be going over exponentials. So exponents are just another way of doing multiplication. It's shorthand for multiplying something by itself. So 3 to the second power is just going to be 3 times 3. So that's why the second power is 2 3s. If you do 3 to the third power, now that's going to be 3 times 3 times 3. So it's really just that simple. Where it gets complicated is when you start throwing in variables, but try not to overthink it. A lot of the times, like, I'll forget exactly how these exponents work, and so I'll do kind of like a test to prove whether I can add the exponents together, multiply them together, or do something to make them simpler. So just real quick, let me explain to you like 3 squared. Super easy exponent, right? So that's going to be 3 times 3, just 2. So this is the number of times that this is timesing itself. This is going to be your base. This is going to be your exponent. Okay? So exponents are just tiny numbers up in the top right corner, and it makes the number multiply by itself that number of times. So this is going to be equal to 3 times 3, and that's going to be 3 squared, which is 9. So 3 times 3 is 9. So that's the really basic exponents. Now we're going to do something that's a little more complicated. 5 squared to the third power, all right? Now the way that this works, I'll show you 2 ways. So because we're not using variables right now, you can actually go through and do the math, which is even easier. So you say 5 squared, let's not use the base 5. Let's start with, because 5 you're going to see is growing way too fast. So let's start with the base of just 2. Alright. So 2 squared is going to be 2 times 2. And so we write that inside the parentheses. 2 times 2 to the third power. So now that you're doing to the third power, you actually multiply it all the way out. So you got 3 of those. 2 times 2 times another one, 2 times 2, times another one, 2 times 2. Alright, and now you can add up all your 2's and figure out what it's going to, how many 2's you have, what the actual exponent is. So 2, 2, 2, 2, 2, 2, so that's 6 2's. So you have 2 to the 6th power. Alright, so this is one thing where students will get this wrong all the time. They'll do 2 plus 3 and say that it's equal to 2 to the 5th power. But that's incorrect, alright? If you look down here, you can see that there's 1, 2, 3, 4, 5, 6. So what you want to be able to do is expand your problems. That's going to be what a lot of algebra is all about, is just expanding the problem to get a better idea of exactly what the numbers you're working with. So if you have 2 squared to the third power, you're going to multiply those. So, and that works if you add a variable. So let's change it to x squared to the third power, and you'll see that that's equal to x to the 6th. Alright? So the idea is you break it down to x times x, and then all the way out, and then you can figure it out. Just for the point of reference, let's figure out what 2 times 2 times 2 times 2 times 2 times 2 is. 2 to the 6th power. So 2 to the 6th power, 2 times 2, that's 4. 4 times 2 is going to be 8. 8 times 2 is going to be 16. 16 times 2 is going to be 32. And times 2 again, that's going to be 64. So your answer is 64. And you can see really quickly that 2 to the 2nd to the 3rd grows really fast. Look at those short, like just little, those are low numbers, right? But if you look at the answer, you see that it becomes 64. That's why they use the word exponential growth. What that means is growing super quickly, all right? So let's try another one. And I've got a deck of cards, which will probably make this a little bit more difficult. They're just randomized, so let's see what we got. And so that's the easy way. Let's try one that's random real quick. So 3 cards. You can go ahead and do those at home. Alright. So 5 to the 4th to the 4th. So you'll see this is going to be a massive number. So what's 5 times 5? Well, that's 25 times another 5 is 125. So we write it all the way out. And we know, because we did this earlier, that the shorthand for this is going to be 5 to the 16th. Alright? Because we're doing this 4 times. So you do all those 5s again, and all those 5s again, and all those 5s again, and multiply all that together, and you have 16 5s multiplying by itself over and over again. Now, I'm not going to do 5 to the 16th, but I will do 5 to the 4th just to show you how fast these numbers grow. So what's 5 times 5? That's 25. What's 25 times 5? That's 125. And 125 times 5 is, I'm going to have to write that one out. So we'll do basic carry. 5 times 5, 25. 5 times 2, 10, 11, 12. 5 times 1, 625. Alright? So 5 to the 4th power is 625. And what you can do is you can then, so then we know that this number, 5 to the 4th power, is 625. So what you can then change it to is 625 to the 4th power. Alright? So that's the simple way. What happens though, what teachers like to do, nefarious math teachers, they like to throw division into it. So exponential growth is multiplication, but as we've talked about in the past, division is just like multiplication, except kind of the opposite side of the same coin. So it's the same as addition is to subtraction, multiplication is to division. So let's check out another number. Let's say we'll do 5 squared divided by 5. Alright, so 5 squared we already know is 25. Well, we can work this one all the way out. We can say 25 divided by 5 equals 5, right? How many times does 5 fit into 25? It goes in 5, 10, 15, 20, 25. So the answer is 5. Now what you're doing here is rather than saying 5 squared times 5, well, that's just equal to 5 times 5 times 5. Alright? So that's going to be 5 cubed. But if we do this one, 5 squared divided by 5, what that is equal to is going to be 5 times 5 divided by 5. Alright? Now the trick here is that we know 5 divided by 5 is just 1. So that's actually equal to just, these cancel out, and we get just a 5 left over. And what the math teacher will tell you is that this is the same as 5 to the first. So what this means is if you have a number divided by that number, you're going to do subtraction. If you have it multiplied, you're going to do addition. Alright? So let's do a simple one real quick. Let's do 3. 3 to the 3rd times 3 to the 2nd, and then we'll do 3 to the 3rd divided by 3 to the 2nd. Now this is really simple. The easiest way to do this is you just add the exponents here, and down here you're going to just subtract the exponents. So this becomes 3 to the, we have 3 and then we take 2 away, so it's going to be 3 to the 1st power, which is just 3. And here this is going to be 3 to the 5th power. Alright, which is what? We can probably do that one fairly quickly. 3 times 3 times 3 times 3 times 3. So I like to use like kind of like an inverted Christmas tree looking thing. So 3 squared is 9, 3 squared is 9, and we just bring that 3 down. 9 times 3, we've done our 9s trick before, so we know 9 times 3, we count over 3, 1, 2, 3, and so it's 27, 27. So this becomes 27 times 9. And again, I'm going to do, so we don't have our 9's trick when it becomes double digits, right? Because we only got 10 fingers, so I can't count all the way to 27 that way. But what I can do is I can do the way that we all learned how to do multiplication, 27 times 9, and now I just do 9 times the ones place, 9 times the tens place. So 9 times 7, that we can do with our hands. 9 times 7 is going to be 1, 2, 3, 4, 5, 6, 7, 63. So you drop the 1s, carry the 6, and 9 times 2, we count over 2, 9, 1, 2, and that's going to be 1 and then 8, so 18. So you drop the 8 and the 1. So the answer is 183. Alright, so that is 3 to the 5th is equal to 183, and so is 3 cubed times 3 squared is equal to 183. Because both of these, this is the 3 cubed part. If I were to underline it in black, that's the 3 cubed part. And then the 3 squared part, I'll underline in green. Underlining in green, and we'll see 3 squares over there. So they're both represented in the long form of equation. And same thing here. We'll say, the way that we draw this one all the way out is we say 3 times 3 times 3, and then 3 times 3 on bottom. Because we know, because we're super smart math students, that this is just division, right? This fraction this is division, but it also means that fraction bar, right? So what we do is we cancel those out, the ones that are there, and it's green, boom, boom, and what's left? Just 3 to the first power. And 3 to the first power is just that fraction bar, right? Alright, so nothing too complicated there. Don't be intimidated by exponents. That's multiplication and division. And what you'll see is like crazy looking fractions. Like x, y, I don't like green. We'll do blue. X, y, z divided by y, z, and then the x is going to be to the third power, y will be to the second power, z will be, well, we'll say y will be to the 8th power, z will be to the 4th power, and then we'll say y here is just y, which means to the first power, and the z is going to be to the 3rd power, something like that, right? So you'll see something like this and you'll freak out because that's way too many letters, not enough numbers, and you don't know how it's going to work. But it's really, really simple. Just take a deep breath and try to, if you need to expand it all the way out, you can write 3 x's, x, 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 and 8 y's, y, 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 and it's 4 z's, and then write the bottom out, and then see what cancels out. Or, if you're a little more advanced, you'll know that you just subtract these. Nothing too complicated. So, you cancel those guys out, this becomes x cubed. There's no x's down here to take away, so it stays as it is. Y will become y to the 7th. And z is going to be z take away z to the 4th, take away z cubed. So that's just going to be z. It's only just one z left, z to the 1st if you would prefer. So it's really that simple. So try not to overthink it. The other way that this, and that's just going to be over 1 because we canceled all these out. Alright? The other way that you're going to see this is in numbers. They're going to say like 64 divided by 8. Alright? Now, if you're a super smart math student, you know that 64 is a perfect square. So this becomes 8 squared divided by 8, which you know, you just subtract those. This is 8 to the 1st and 8 to the 2nd, so you subtract them out and you know that that's just 8. Or you can always just do the division and see how many times 8 is going to fit into 64. Long division. So top dog gets the house. You put 64. 8 is on the outside. How many times does 8 fit into 6? It doesn't. So how many times does 8 fit into 64? Well, I think it's 8 times. Let's see. 8 times 8, 64. Subtract equals 0. So you'll see that both of these are true. And so that proves the point that you can actually just subtract the exponent to get your solution. All right? If you guys have any trouble with the exponents, don't hesitate to hit me up. They're super, super simple. And yeah, have a great day, guys. All right, this has been Gamonal Tutors, where confidence breeds competence.